Okay guys, so here's my CNC that I built. It's a Gatton CNC. It's one that you can build yourself. It's about 54 inches wide by 72 inches long. It gives me a cutting surface area of about 40 inches on the x-axis by just under 60 inches on the y-axis. So nice setup. You can scale and build these yourself to your own specifications, and I quite enjoyed it. I went a little bit different than his recommended system, which is a Windows-based system with Mach 3, because I didn't have a standalone computer that I could use, first of all, and second of all, it seemed to be a little bit less expensive to go the Raspberry Pi route. You could have a Raspberry Pi computer as well as the breakout board for about $70, I think, and as opposed to me having to do the Windows setup, it'd be about, you know, whatever the cost of the breakout board is. I've seen some at 20 and some at 70 and some at 100, plus the cost of a computer, again, which I didn't have, and I wanted to go a little bit more inexpensive for the initial start of my setup. And I figured at the end of the day, if it didn't work, I could always turn the Raspberry Pi into a video game emulator. I have no prior Raspberry Pi experience, so I thought, what the heck, two birds, one stone, I can try it. So I built the machine. It took me about a month. I'm still finishing it. There's a lot of wire management and whatnot that I still have to go and do, but I was having a lot of trouble on calibration. There's a lot of videos that are out there, but it seems like all the videos are for Mach 3, and frankly, they are just too difficult and confusing for me to try to get the information on Mach 3 and transpose it onto Gerbil or the bCNC program that I'm using on the Raspberry Pi. So I thought I'd take a moment to kind of show you what I went through and how I got my machine to calibrate properly. So first of all, you come over here and you click on Terminal. If you click in this box right here, this is the command where you go to program your machine and adjust it. You type in $2 signs, $, and you're hit with a series of $sign numerical values. These are different configuration settings that you can use to adjust your machine. Now these are numbers for my machine as it currently sits. They will most likely adjust, and they will definitely most likely not work for your setup, but suffice to say that all these different settings are things that you can adjust, and I'll include a PDF description of all the things are in here and what you can do with them in the description below. But today we are going to talk about these three numbers: $100, which is your x-axis, $101, which is your y-axis, and $102, which is your z-axis. Now, it seemed to me like when I watched a lot of videos, a lot of people were using this ruler setup. You have your machine turned on, set up, you put a ruler down on the table, and you go a certain distance, say here to here, and your machine is supposed to say go 100 millimeters, and it either goes 80 millimeters, 110 millimeters, so on and so forth, and you adjust. And if you've seen a lot of videos like that, then you may or may not have run into the same issue that I have. I actually took the time to do this initially, but I went on a larger scale. I got a measuring tape and I went from here all the way to the back of the machine, and I had the router go 1,000 millimeters this way and 1,000 millimeters back. And based off of those numbers, I was able to come up with a series of numbers for those three settings that I mentioned a moment ago, and I hit enter. And everything I thought was all well and good. And I did that for X, Y, and Z. However, the other day I went to go make my first test cut, which was for this piece right here. This is going to be a part of my dust shoe so that I don't have so much dust. You can see I just barely used my machine a few times. There's a lot of dust. And it didn't come out exactly perfect. Now it looks good at first glance, but this cut piece right here actually took two separate router bits. And the first set was this cut right here, which was a 1/8 inch compression bit is what I used, and it cut that out, and you can see it came out to a very nice circle. Everything else was cut out using a 1/4 inch end mill. And if you noticed already, this section right here is thicker than up here. As a matter of fact, it was so thin it either broke off or disappeared completely. So what that told me is that after all that back and forth, my machine wasn't properly calibrated on my X, Y, and Z axis. So, you know, I don't know if you guys are aware of this or not, but once you do your first tool path using your first tool, say for my situation, this 1/8 inch compression bit, the machine always travels back to home. Well, I didn't mark my home, and once I hit start, the machine didn't exactly go back to the original 000 destination, so it shifted just a little bit. And it seemed like everybody in the videos that I was using would do this method where they would say, oh, I want to travel a certain distance, and if I hit, say, the keyboard to travel to this way 100 millimeters, which would be 10 centimeters, I just do that, and if it travels and it gets to 20, I'm good to go. Well, that doesn't really work. Once the machine starts to go and it starts to make cuts, the small micro adjustments in your system start to compound, so that by the time you end up at the end of your cut, you kind of end up in this kind of scenario. So you have to do something a little bit more substantial and detailed in order to calibrate your machine better. And so I found cutting one of these squares out of a piece of MDF worked out really well for me to make the adjustments that I needed to get my machine properly calibrated. So you can see it's just a square that I cut out, and there's a piece of it cut deep to test the Z-axis settings, and I used that in order to properly calibrate my machine. And so you'll see right here, after I cut this first test piece right here, this is the first piece that I received. And I still have to tram the machine. I'm waiting, it's on back order for the tramming gauge. That'll be a separate video. But I wanted my machine to cut me a square, which is this piece 150 millimeters by 150 millimeters, and cut this 14 millimeters deep. And this was the current settings in my X $100, 101, and 102. That were the three numbers that were in the computer currently. Now, this and this yielded these numbers right here. I was actually a little small. I was at 148.7, 149.2, and 13.7 millimeters. So in order to come up with the new 100, 101 settings, what you have to do is you have to divide this number, 62.970, divided by 148.7, and that number needs to be multiplied by 150. That will yield you 63.521. You do the same thing over here for Y, 62.986 divided by 149.2, times that by 150. You got 63.324, and 69.336 divided by 13.7, multiply that by 14, and you got 70.854. Now, I don't have the best calibration tool in the world, frankly. This is an Amazon choice. It was about $15 or so. So after this first test kit piece, I put these settings into the computer, and to do that, you come down here, once again, and you type in $100 equals, and so in this one I would just do 63.521, 63.521, and then you hit enter, and it automatically changes the adjustments. And you do that for all three. So then you would do $100 equals 63.521, $101 equals 63.324, and then $102 equals 70.854. Once you do that, you come back over to your machine once again, and you type in $, at least I like to, and you come and you double check your settings to make sure that these numbers reflect the numbers that you just input, to make sure you didn't do any typos. I didn't actually change them. So once I did that off this first test cut piece, I moved on and did a second test cut piece. So once again, I wanted to cut a 150 by 150 by 14 millimeter square, and that's what this piece was supposed to be. These were the settings right here that I had for the $100, 101, 102 that I had received over here. So I just moved them over here to this test piece for my own references. And when I used these settings in the system, instead of getting these numbers, I ended up getting these numbers. So I went a little bit big. So I was at 150.4, 150.6, and 14.2 millimeters instead of these numbers over here. So just like we did on this first step, I moved on and said 150.4 divided by 63.521, multiply that number by 150, yielded me a new number of 63.352. Same thing, 150.6 divided by 63.324, multiply that by 150, yielded me 63.072, and 14.2 divided by 70.854, multiply that by 14, yielded me 69.856. So I went into my system once again and put these new numbers in for my 100, 101, and 102, and moved on to my third and final test cut piece. So using those three numbers in my settings, I had 150, 150, and 14 millimeters. I actually was able to get exactly 150, 150, and 14 millimeters using the settings that I had put from step 2. So I left those numbers here just for a point of reference. And if you notice, my first numbers were 62.970, and I was too small. And then I moved over here to 63.521, and I was too big. And then the Goldilocks for me was 63.352, which is directly in between that number and that number. So I don't know if it's my calibrations or if it just takes a few of these test pieces in order to get a good accurate number, but it took me 3 test cuts to come up with these numbers, and now my machine is properly calibrated. This is 150 millimeters, this is 150 millimeters, and my machine cut 14 deep.